Hello everybody. So this is a new course which is started on data analysis. Course started with data analysis. A lot of people do data analysis with many things, with Excel sheet, with Python, but I decided to show you how we can analyze data with R. And as you can see on my screen, I would be using RStudio. So now we will start with a basic script in R. But I'm going to, as you can see, this is hash is also the way to comment out something when you use R the way it is in Python. So the first thing we do with R is we can do arithmetic operation. So arithmetic operation, like you want to add two numbers together. So want to add two numbers together, arithmetic operation. So let's say you want to add 3 plus 2. So command enter. So it prints out the answer to you in the console. So the console is this, where you find the answer to what code you write here. So you can do more, you can say 5 divided by 2, command enter, 2.5. You can say 7 times 5, 7 times 5, command enter, 35. You can say 7 raised to the power of 2, command enter, 49. So all of these are basic arithmetic functions you can do with R. So we're going to do more of these after now, but these are the basic scripts we usually use R for. So we can also assign a value to a variable. So we can do we can assign a value, to a variable. Since we're using these for data analysis, we will not be beating around the bush too much. We would focus on the very important thing. Now, let's say, for example, I want to assign a value to x. So I would say x is equals to 7. So if I run it, it's already assigned. It's assigned here already. So if I want to do basic work, I would just say x raised to the power of 2 or x. Let me try this way. So it's 49. And sometimes you can decide to use raised to the power by saying x raised to the power of you can use a sign, same one. You can use a sign raised to the power of 2. So it also working on to use that sign. So you can use the raised to the power in these two ways. You can either use this way, or we can use this way. They both work fine. So, but a good practice is to include comments. Like I used to tell people, this is something very good when you're writing scripts, or when any code you're writing. It's good to write a comment so that people who would come after you would be able to know what exactly you did and how it actually worked. They can say, this is a short script. You can say this is, so but when you want to write a comment, you write hash. You can say this is a short code that can be used to solve quadratic problem. So this is a short code to solve quadratic problems. Now let's assign values to solve this. Let's see an example of how to solve quadratic problems. We'll say A. Remember I told you this is algebra equals to R. A is equals to 7, for example. and b equals to 8, and c equals to 9. So these are three variables, a, b, and c. Then we can calculate these two roots of the equation. We can find the roots, the quadratic, use a quadratic equation. So calculate the roots, square root. You can calculate the square root. Excuse me. Square root of the equation. You can also use the quadratic formula. We can use the quadratic formula. So anyone who comes by, so the quadratic formula usually be like b negative b plus the square root of b squared minus 4ac over 2a. So this is how we usually write it in in this we usually write this formula like this. I would write it with my pen to let you see how it's been written first. So we usually write negative b plus the square root. Is this? I think it's plus negative b square root of b squared plus 4ac divided by 2a. So this is how we usually do it. We usually write this with a pen. So if I'm not mistaken, you can check online yourself to be sure that I'm writing the formula in the proper way. So now, if you want to type this into R, is gonna look almost similar. So how would it go? So the first thing is you're gonna open a parenthesis. So you write negative b plus the square root. So how do you write square root? In R, you write SQRT. You write SQRT. So then you open a parenthesis again. So square root of b squared. You can either write a b squared like this, or you write it like this. This way you write it is the same, but I would write it like this. B raised to the power of 2b squared. So minus 4. 4ac is 4 times a times c. I think you know that. 4 times a times c. And remember that you have to divide it, and it's how to do that in R. Divide by, open a parenthesis, 2 times a. So this is it. So this is exactly how to generate a formula. Mind you, you already assigned a value for a. Let me enter this. You assign a value for a, you assign a value for b, you assign a value for c. So by the time you run this, so it says NaNs produced, says no value is being produced. So let's trace it and see what that actually means. So it says you don't have enough value, that is to say some values probably is more than what we have. So let's go through the codes one after the other and see if there is a problem somewhere. So it says, mind you, we said negative b plus SQRT, which is square root of b raised to the power of 2 minus 4 times a times c. So I think this is okay here. 4 times a times c divided by 2 times a. So probably the values we gave is not very accurate. So I think this C, let's put a negative value in the C. Say negative 9. So let's run it again. So now it's got the good answer. Because sometimes if you're given it, I guess these numbers from my brain, so it could give us something wrong because it's not working with it. And I remembered most of the time it's good to put your C as a negative value. So mind you, the what we did here, we said negative, thing is negative and positive. So we can also we can try we tried a positive here. So let's do the same formula and use a negative value now. So let's try to do the thing again. But now we're going to use a negative instead of positive. So let's try to run this and say command enter. So the value is also different. So the answer is either positive 0.698 or negative 1.84. So this is how we usually work with arithmetic function in R, and it's nothing, anything you want to do, any formula you want to have, this is the way you do it. So let me remove this formula here so we can learn more about the R. So the next stage we're going to move into now is how to install packages. So we're going to move on to installing packages. So we're not going to waste time. We're not going to mess around because this is specifically for data analysis. So how do we install packages in R? It's not pretty difficult. You just have to write the codes like install. You say install with a double L. Install dot packages is already brought it out for you. So let's say, for example, I want to install tidyverse is a package. So use a double quote. You type the package you want to install, tidyverse. So and what you do, command enter. So it's going to install the package. So now you can see the packages have been installed already. So, and I think I already installed this before. And if you want to check if the package is already there, how do you do that? You say library. So you tab library. So when you type library, you type the name of the package. This time around, you're not going to put it into quotation. You only put it into quotation when you want to install this package. But once you want to, if you've already installed the package and you want to check if the package has been installed, you just write library and the name of the package and command enter. So it's going to tell you, wow, now the package is already there. And there might be some little bit of errors here. So the filter is being masked, starts to filter and deploy. So use the conflict package to force all conflicts to become error. So we can do this in another way where we can do, it says, so this is how to solve the problem, but we're not going to dabble into this now because we want to focus when we try to do the main data analysis with it, then we can fix it. So now there's another thing we call the workflow. So the workflow is most of the time is going to show you where you save your work, or you can sometimes save your work in cloud account. So you can see the cloud file by clicking on the file tab. And sometimes you will see, it depends on what you want to save the file. Sometimes you want to save a file in cloud. Sometimes you want to have it on your desktop. Sometimes you want to have it in some other places. And when you save it, you're going to actually find it. So if you're using a desktop version, then before saving anything, you should set the working directory. So set the working directory where you want to save the file. So let me say, for example, you want to see where your working directory is here. So it's a file package of all of this. So we want to use, if you want to set your working directory, you would set it from here. If I want to set my working directory, for example, to be my document, so I can use my document as my working directory. So everything I save, everything I do here would be saved in the working directory. So for example, let me name it data analysis. Data analysis with R. So I want to save it. Let me save it in my desktop. So next time you're gonna find it on my desktop. So then I save it. So I've used the desktop is now my working directory. So if I decide to close this anytime, any day, and I want to get it back, I would just go to my working directory, can go home here. So then I would look for my working directory, which is my desktop. So find it here. So what did I name it with? I called it data analysis. So find it data analysis. This is it. You click on it. So once you click on it, it's going to open for you, because this is the working directory. So now it's open. So this is exactly how you do a working directory. We have some other ways of doing it, but we're not going to bother ourselves much about that now, because we still have a lot to do. So when we get down to the main place we want to work, so we're going to be able to see how we do that properly. So now we want to move on to the next level. So the next level is we want to work with data visualization. So one of the primary job of data analyst is for you to be able to communicate the meaning or insight from your data. So a very good way to do this is via your visualization. So, and it's a very good practice to be able to know how to visualize your data. So we would use the library tidyverse in this analysis. So I can decide to clean all these things. If I want to clean, I can just click on this this broom, so it clears everything. So if I want to work with this, I just run the library tidyverse. Remind you, I already installed it before. So it's an updating. Do you want to restart our page update? Okay, let me restart it, and then we have it been installed again. So then both the tidyverse and base out, we can they have some data, which is inbuilt data that you don't need to download the data from anywhere. It's already inbuilt inside them. So one of the most used one is the MPG data. So the MPG data is the data that actually talks about automobiles and talks about some characteristics about this automobile. So let's say MPG. So we should start MPG, then you run it. You didn't find it. I don't find MPG data. So the library which I already installed is a tidyverse. Probably the library doesn't have MPG. So how do I do it? So the first thing I did, I try to install the packages, and I install the tidyverse, and I checked out the library. So let me install the other the package. So I would install another package called ggplot. So ggplot2. So I would install it, and I would check it out by using the library keyword. So I would check out if the package is in by using library ggplot2. ggplot2 is a very important library using R. So now it's there. So I would then call the MPG again. So now I've got the MPG. So it shows you that MPG is actually a data which is inbuilt with ggplot, not with tidyverse. So this is a beautiful data. It's in table. It's a table data. It's got 234 rows and 11 columns. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So it's got 11 columns. This is the manufacturer of the table of the data. I mean, of the cars is Audi, the ones on the top. We might have more, but this is just the first 10. The model is A4, and this is A4 Quattro. Then this is the display. Is also these are characters. CHR is character. So because they are strings, and A4 is also a character. This is DBL, so 1.8. This is an integer. This is also an integer. This is character. This is character. Integer, integer, character, character. So the R itself will classify these are the variables based on what it wants to do. So if you want to view properly, use a view keyword, which is the way to see the data in a very good way. So it's a view MPG. So it shows you the data in the table format. So now we can see the data in the table format here. So, and we can see after the Audi, you have a Chevrolet Suburban 2-wheel drive. Then we have Chevrolet, we have Malibu. These are types of Chevrolet. We have Tahoe, we have Caravan, Dodge, we have Dodge. We've got Ford Explorer, 4-wheel drive. We've got Ford F-15 pickup. We have Honda Civic. We have Hyundai Sonata. We have Hyundai Tiburon. So this is the year they were made, 2008. So this is the CSA. So you can have more information about this data if you want to do by going back to the coding platform and use a question mark. Use a question mark and write the name of the data set, MPG. So this is more information about it. So fuel economy data from 1999 to 2008 for 38 popular models of data. So the data set contains a subset of fuel economy data EPA makes available. So you can click on this and you will know more about it. So the display means just to know, have more information about the variables. You've got manufacturer name, that is the manufacturer or the like. So then you have a model, the model name, the model of the car. Then you've got year, the year of manufacture is, so the display is engine displacement in liters. So the engine displacement in liters is 3.8 to 3.1. So, and some of them, Mustang has got 4 up to 4.6. And we've got Ford Mustang up to 5.4. The year of manufacture. So this is cylinder, the number of cylinders they have. The number of cylinders they have is high in Ford cars, and also in Ford cars, we've got 8 cylinders. In Dodge, we also have 8 cylinders. So 8-cylinder cars, the more fuel consuming. And we've got transmission. Transmission means is it automatic or manual? So we've got DRV, it says the type of drivetrain, F front wheel, R rear wheel, and 4-wheel drive. So the front wheel is F, and the rear wheel is R, and the 4-wheel drive is 4WD. So the city miles per gallon means citywide means city miles per gallon, and HWY highway miles per gallon. So the FL is fuel type. We've got a different fuel type. Is it petrol? They didn't mention that. P, I think, is for petrol, and R is for maybe diesel. So it didn't talk about that. The class is the type of the car, SUV, middle size, subcompact, and all of this. So this is more information about the data. So sometimes you're working with data set, you need to get more information about it. And once you do this, it's going to give you more information. So let's quickly generate a kind of visualization about the data set. So the first thing you do if you want to create a visualization, you call the ggplot. Then you open the parentheses, you say data is equals to what the data is, MPG. So mind you, this is the first block of codes you write if you want to get information, you want to see the visualization for a data set. So if you do this, then you write a plus. So meaning you want to add more things. So once you write the plus, the R would understand that you want to write additional information about, you want to write more block of codes for the same information. So in this case, you want to create a geom point visualization. So you say geom point. So then you open a parentheses, you say mapping. So you want it to be in the form of a mapping. And after that, you want the mapping. What do you want to map? You want to map AES. AES is aesthetic. It's called aesthetic mapping. So the aesthetic mapping describes how variables in data are being mapped to visualization properties. So aesthetics of aesthetic mapping can be set into GPP by writing the ggplot, open the parentheses, and use the individual layers. So, and AES, the aesthetic you want to use is you want X to be the one that display. You want X to be the one that display. So you would look at what you want your X to be. You want your X to be display, that is what you decide. You want your X to be something else, that is what you decide. So you want the X to be engine displacement in liters. So you say this, mind you need to know how it's been written. It's been written DISPL in the variable, comma, then you write your Y. What do you want your Y to be? Depends on you. I want my Y to be HWY. HWY, what does that stand for? That stands for highway miles per gallon. So this is what you want to see. You want to see this visualization. Check everything and make sure everything is fine. ggplot data is MPG. Geopoint, you want to have a mapping as aesthetic, and you want to have the X to be X axis to be displayed. You want to have the Y axis to be HWY, which is highway miles per gallon. So you command enter. So voila, you have the data, you have a graphic, you have your visualization. So this visualization is pretty okay. So you show this is the display here, and this is the what do you call it? This is the HWY, highway per liter. So you would see highway per liter, we've got up to about 40, and that about 40 goes for, let's say have a table. That about 40, it goes for what kind of cars? This is Volkswagen. This is Volkswagen. Volkswagen is got 41 and it's got 44. That's new B2. So, and that is higher. So, and you got the display being spread out to up to 7. So which car has got the display up to 7? So which car has got all the displacement up to 7? So it might be small cars. It's got 6.1. That is Jeep Grand Cherokee 4-wheel drive. So, and I've got 14 highway per. So what does that mean? That it's got a lot of information which you can break down for anyone who wants to know more about it. So you can also make these bigger. You can zoom it, you can export, you can save as image, you can save as PDF. You can clip to the, you can copy to clipboard, wherever you want to do, it's fine. So, but let's try to make it bigger in size, say, or not that way. So we can, that way. So you can export this. Let's export these as PDF and see how it's gonna say. So I already exported that. So you can decide to zoom in. You can decide to zoom in. Now we zoom in. So the data is being seen in the proper way now. So this is how we can create some visualization for yourself. And this was going to give you more insight about what we did. So we will take a break here before we continue with the rest, hopefully. Have a nice listening. So after we've been able to do this, we can as well add more information to the data. For example, we've done ggplot, we've done data, MPG. We've been able to find the relationship between display and HWY. So we can also add another information. So let's say, for example, we want to add a color. So what you do is it's not difficult. Just put a comma here and put color. So put your color. You want to put, what do you want to put the color? We want to put class. So now let's bring it up into the normal thing. So just close this and say comma. So you put color. So you want the class to be the color. So you put class. So, and try to run it again. And you will see there will be a difference in it. So if you can have, so let me run it again. So now can you see? So the class means the type or the class of the car. If you see the car here, we've got the class. So the class stands for the type it is, SUV, two-seater. So as you can see from this visualization, we can see the two-seaters, they range between 20 in the highway transmission stuff. But let's take a look at the display. So we've got the display for the two-seaters is highest here, 7. So 7, and mind you, I think you know what the display actually represents before. So the compact it ranges between 2, and it ranges between 35 to 40 in the HWY. So this is how we can do more. And if you want to know more about the jump point, if you want to know more about jump point, just say the same way I did the other time. Just put a question mark, put the jump underscore point, jump underscore point, and it's going to give you all the information you need about jump point. So this is all the things you need about jump point. So mapping, you put it null, data null, as statistics, identity, position, identity, NA, RM, false, show, legend, NA. So all of these things are how we can use a jump point very, very well. So we have alpha, color, field, group, shape. We're going to talk about what all of these things, what they represent, and we're going to talk about how we can put that into our data analysis using R. So we have more things we can do, and we can also decide to label. So we can also decide to pull the jump point. We want to pull let's do another visualization here. Let me copy and paste this. Let's make another visualization. This time we want to have a AES. We want to have a jump point. We want to have an AES into bracket display. So we don't want to have X as display. We want to just have the AES. We want to have display. Then we want to have HWY. We don't want to have it as Y, just want to have it. Then we want to have the color as the CYL. Yeah. We want to have the color as the cylinder. So we want to have the cylinder, and we want to have a cylinder which is less than, for example, 7. So we want to have a visualization for cylinder which is less than 7. So now this is a visualization for cylinder which is less than 7. So now we've got the HWY, and we've got true and false. So the meaning is a cylinder less than 7, true. These are the ones which the cylinders are less than 7. We could see a trend in these ones with a cylinder which is less than 7. So if the cylinder is less than 7, the highway fuel consumption is really, really low. So it's really the highway fuel consumption is high, sorry. So the cylinder is less than 7, less than 4. Let's say, for example, 4 below. So let's check that out from the table. So let's see when we have the highway. So this is highway. We've got 26. We've got 40. So what trend do they have? So let's check the cylinder. So let's check the cylinder for them. So cylinder ranges around 4. So the cylinder, when it goes to around 8, the highway something is gone to around 22. So and for this it's got 13 for Ford when the cylinder is, which is 8-cylinder. So the highway is gone to 16. So this is got a very great information to tell us. And we can as well even give labels. We can label what we're working on. We can give labels to them. So, and how do we give labels when we are designing? where we're making a visualization, because the labeling would have a lot of information to pass across. So I would try to show you, I would try to do another copy and paste this so that we run and have our data back. So the same way you call it ggplot, but this time around, you're not going to pass the data, just pass ggplot mpg. So you want to use all of the data plus geoplot. And this time around, we're going to use a mapping. We use a mapping as AES. So then we want to have an X. We want to have an X as a display. We want to have an X as a display, and we want to have a Y as the HWY, which is highway consumption. And we want to have the color as a class. So we want to have a color as the class. So we want to have a color as a class. So if you want to add more information, the way you do it, the way I mentioned all the time, you add a plus. So once you add a plus, it's going to know that it will still continuing with the codes. So you want to have a labs. So before we move on, so we want to have a labs. The labs is actually used for type 2 waiver or some other things you want to work with. So you've got the X. You've got X is equals to, what do you want the X to represent? You want the X to be labeled as, that is what it means. The last means label. So you want to label the X as engine displacement, engine displacement. And you want to have into a bracket, you want to have a capital L. You want to have a capital L. So engine displacement. And you put a comma because you still continue with it. You put a comma and you write your Y. Remember, it's a not capital. Uppercase Y. What do you want to label your Y with? You want to label your Y with highway. Use a lowercase. You want to label with highway fuel efficiency. Highway fuel efficiency. Highway fuel efficiency. Efficiency. Open a parenthesis and write MPG and close the parenthesis. And since you want to continue to write something else, you just put comma and then you write the color. So you write color. Mind you have to let it be here. So you write the color. So what do you want the color to be like? You want the color to represent the type of the vehicle. So type of the vehicle. You need to write it the way it's been written, vehicle. So now this is amazing. So then you close your parentheses. So you could have some errors sometimes. Maybe you forgot to do cover some parentheses properly, because now you show me a sign here. There is a problem somewhere. So we can run through the code again. ggplot, open the parentheses, mpg plus jump point mapping as AES. Then open the parentheses, the X is display, and the Y is highway fuel efficiency, and the color is a class. Then we want to add the labels. It's called labs. So the labels is labs. We want to have an X to be engine displacement. So engine displacement, we should not have this here. So we should not have this. So we should remove this. This is a problem. So we want to have engine displacement. So that's gone. So we want to have the Y to be highway fuel efficiency. And we want to have a color to be the type of the vehicle. So then you come and enter, you run it. Now we have it. So this is Casina. It looks more beautiful. And now you can export these as PDF. You can export that image. You can save it. You can preview. You can export as. You can preview that. So now you can see how beautiful it is. So you can easily copy these and put in your research paper. So it's beautiful. So this is exactly how we use this. We use R for visualization. And hopefully we're going to have to stop here for today. And by the next class, we're going to continue to let you see how we can do more visualization with R. Thank you very much.